So now, a lot of people that watch my videos are completely new to electronics, and a lot of people haven't bought, electronic stuff. You don't need to spend a lot of money to learn quite a bit though. That's the good news. That's what I'm going to demonstrate here. So here I have a power supply that's somewhere around $100, maybe like $130 or something. And so not completely cheap. You can get batteries, pretty cheaply and stuff if you want. And you may have to change the value of the resistor right there to protect the LED. That's basic electronic stuff that you learn. But in case you just need a power source, you can go cheap. This power source is really good for these videos, though it lays flat here so you can see the display and whatnot. I have it set to 5 volts, and those alligator clips are coming to the board to power the board. You can get breadboards for, about $1 or $2 if you get really cheap ones. And really cheap is just fine. For beginning to learn, you got to find a way to connect the power though. I have these little header pins down there. You can also just take one of these jumpers. These jumpers come in a lot of kits, and clip one side there and then clip the other side to the part of the breadboard that you want to power right there. And you can use a jumper to go across and power the other side and whatnot. I have these ones that I made right there. You can buy wire. So again, these basic things, they don't cost a ton, even starting out. When you're first learning electronics, get a bunch of cheap stuff. But in case, we're going to come back to the circuit. This power supply is really nice. There's a lot of power supplies. You can get cheaper ones, and ones that can handle more power and everything for cheaper. This is a handheld one, so it's a little more expensive for what it provides. But there you can see, this load needs somewhere around about 10 milliamps of current. This is not as accurate as a multimeter, but it's not too bad. It might be 1 or 2 milliamps off. You still get a pretty good idea how much current is flowing. So this will cut out at 20 milliamps of current, and I just short-circuited it so it turned off. But if it didn't turn off, it would maintain 20 milliamps of current. When it senses there's no resistance between the positive supply and the negative supply, a short circuit, it shuts itself off. Something to be aware of. So I put it back there. It stays off until I hit the power button. So that's something that that's protection right there that you won't get if you just use batteries. But again, these are cheap components. If you use like AAA batteries or something, they have their own limit of how much current they can provide. It's not a good idea to short circuit them, but if you do, you're not going to be frying the breadboard or anything. So in any case, we come back. Now we got the switch controlled LED right here. Here's where you can use cheap components. A lot of just like a $20 component kit will come with like a breadboard and everything. Might have a little battery holder that you can use batteries for and whatnot. Resistors, LEDs, switches, all that, maybe even these jumpers or other jumpers, the ones that are just kind of wires. So we have this long wire though, because I'm going to be moving things around. We have the on-off switch. We can make an AND gate out of this really simply. So now instead of going to ground, I go to this switch over there, and then I take this jumper and I connect that to ground right there. So now we just made a slight modification, but we made an all new circuit. So press that button, the LED stays off. Press that button, LED stays off. There's 4 different states, and 3 of them the LED is off. We just saw those 3 states. One of the states is not pressing either button. I gotta press both buttons right there to turn the LED on. So one of the ways to look at an AND gate is that you need all inputs on in order for the load to be on. And there's also other AND gates that work on voltage and whatnot. This is an on-off situation right there. Pretty straightforward. Now, we are going to look at the OR gate. So I have these jumpers that move around a lot. This I just had wire, and I cut them, same wire I used right there, that black wire. So you can make, a breadboard jumper like that. That's a jumper cable. This would be a jumper cable because it's solid wire, not really meant to bend a lot. This is a jumper wire right there. It's stranded wire in there. It's made to bend a lot, many times without really getting weaker each time. And so of course every time you move it, it does get a little bit weaker, but these solid wires get weaker a lot faster right there. So I'm going to the top of that switch, top of that switch. We're just making a real quick OR gate. So I don't need a schematic or anything. And so we come down to the negative supply right there, and now I can turn this one on. The LED will turn on, but not that one. We need a little bit more. So we need the this bottom of that switch right there going to the bottom of that switch. So now we can complete the circuit through this upper switch right there, or the lower switch right there, or both of them. So when you got two inputs, two switches, there's 4 states. So right now this is one of the states, that's the other, and that's another one for 3, or just leaving them both off, that's a 4th state right there. So any case, we spent about 5 minutes here. You know, I discussed like the power supply and stuff, but in case we saw, you know, a few circuits that are different from each other. You know, not super different or anything, but you know, learning electronics is mostly, I would say, taking, you know, simple circuits. First off, adding them together. A whole bunch of simple circuits make a complex circuit. Complex circuits are not completely unique from simple circuits. It's just a bunch of them put together. And there's a ton of simple circuits you can make all by themselves as well. So that's really about it. Of course, you got to learn what value resistor to use based on the load that you got, the voltage you're working with, and all that. That's stuff you learn in electronics. But when it comes to actually building the circuits, just doing these really quick, simple builds on, you know, a cheap breadboard with cheap components and everything works really well. I understand higher power systems better because I made so many simple circuits as well. The principles of the simple circuits apply to the larger ones. There's just more things you got to worry about with the larger one in addition to that. But knowing the simple stuff ahead of time helps out a lot. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.